In this section, we want to learn about addition and subtraction of polynomials and polynomial functions. When I write DEF, that means definition. A polynomial in X is a finite sum of the terms of the form a times x to the power of n, where this a is a real number and n is a whole number. That means positive integer. Here, x is a variable. That means unknown number rather than fixed number like a. This a is called coefficient, and this is written as a times x to the n power. This power n, which is associated to the variable x, is called degree n. In the example, we have 3 times x to the 5th power. In this case, 3, the fixed number, is a coefficient, and this is the degree. 5 is the degree. In this example, 7 is coefficient, and u is degree 1, because u can be written as u to the 1 power. What may be a little bit confusing is if I write 2 to the 5 power times x, then what is the coefficient? The coefficient is 2 to the 5th power, and the degree of this polynomial is 1, because this can be regarded x to the 1 power. So what you have to remember is degree is associated to the variable. When we say the given algebraic expression is monomial, that is polynomial with exactly one term. So in this example, we have 5 times x to the 8th power. So it has only one term, so that's monomial. When we say binomial, binomial is a polynomial with 2 terms. In this example, there are 2 terms, so this is binomial. So each of them are called term. So there are 2 terms. For your reference, the terminology is, in this case, 2 numbers are multiplied. So we can say this one is 1 factor and this one is the other factor. Trinomial is a polynomial with 3 terms. In this case, we have 1, 2, 3 terms, so we have a trinomial. General expression of the polynomial of degree n goes like this. We write the highest degree term first. The general term can be written as a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 plus da 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 plus a sub 1 x plus a sub 0. This ai associated to the variable x are real numbers. Those are coefficient. We are talking about degree n. Therefore, this a sub n, which is associated to the highest power of x, cannot vanish. If a sub n is 0, then the highest degree term will vanish, so the degree will not be n. So a sub n is not equal to 0, but all other coefficients a sub n minus 1 to a 0 may become 0. So a sub n has a special meaning that makes the degree of the polynomial determined, and that is called the leading coefficient. This is the conventional expression of the polynomial of degree n. Remember that the standard notation of the polynomial write in a descending order of degrees. As I said, the degree of the polynomial is the highest degree. When we have 7w plus 3w to the 5th power plus 2, then this is degree 5 polynomial, because when we think about this one is degree 1 term, and this is degree 5 term. In this case, we can assume that's 2 times x to the 0 power, so the degree 0, which is usually called a constant term. And the leading coefficient is associated with the highest degree term, so that's 3. Leading coefficient is not the number that appears first that's associated with the highest degree term. The conventional way to write this polynomial will be highest degree term is degree 5, so 3w to the 5th power plus the next one is 7w plus 2. Now we want to combine the polynomial by adding or subtracting. When we do that, we have to simplify with like terms. Like terms are terms with the same variable and the same degree. In this example, we have variables x and y. So we have two variables. We want to think about the like terms. The first term is 11x cubed. When we determine the like term, the variable must be the same and degree must be the same. So degree must be 3 and variable must be x. So this is the like term. So 11x cubed and 35x cubed are like terms. When we think about 4x and 5y, those are not like terms. Why? Because those are not having the same variable. One is x and the other is y. And when we compare the next two, 5y and 9y squared are not the like terms because the degrees are different. Addition and subtraction of polynomials. When we add or subtract polynomials, we combine like terms to add or subtract polynomials. When we say the polynomial is the opposite polynomial of the given polynomial, that simply means each term opposite sign. That means we multiply by -1 to the entire polynomial. So when we write like this, minus open parenthesis 3x minus 5y plus 11, that means we are multiplying -1 to this polynomial. When we simplify, we have to distribute. So -1 is applied to 3x, the first term, minus -1 is multiplied to 5x, second term, and -1 is applied to multiplied to 11. So -1 times 11. When we simplify, the first one will be -1 times 3, which is -3. And then negative will make positive, so plus 5y, and then minus 11. Many students are confused with this distribution law, and when minus is applied to this parenthesis, they tend to remove just a parentheses and apply this multiplication only to the first one. That is not correct. Always be careful if minus is written in front of the parentheses. You have to apply minus to the first, second, and third term. Other property you know is when we write a minus b, that means a plus minus 1 times b. In this case, a and minus b are not multiplied. We are subtracting b from a. Let's simplify. This algebraic expression can be written as 5x cubed plus 2x minus 1 plus minus 1 times 11x minus 2, and we distribute minus to the first and second term. Then we have 5x cubed plus 2x minus 1 minus 11x minus 1 times 2. This one is 5x cubed plus, we combine these two, then that'll be 2 minus 11 times x. Then we have to calculate these two, then that'll be minus 1 plus 2. So that's 5x cubed minus 9x plus 1. The next problem is similar, but it has two variables. Let's rewrite this as 5x squared y plus 6 minus xy plus minus 1 times 7xy squared minus 2xy. Then, as we did, we have to distribute minus 1. Let's rewrite it. 5x squared y plus 6 minus xy minus 7x squared xy squared minus from here, and then minus is multiplied to xy. When we combine these two, this one will be plus. And then we have to think about the like terms. There is no like term for 5x squared y. And we find that this xy and this xy are like terms. Let's write 5x squared y plus 6 minus x y plus, from here, 2xy minus 7xy squared. How can we interpret this? This one is minus 1 times xy plus 2xy. So xy are common factors, so we can rewrite it as -1 plus 2 times xy. That means this is 1 xy, which is xy. Let's rewrite it. 5x squared y minus 7xy squared plus xy plus 6. Why is that? Because there is no other like terms. And when we write the algebraic expression in a conventional way, I said we would write it in a descending order of the degree. The first term has degree 3 because this one is x squared and this is y to the power of 1 and this is x to the power of 1 and y squared. So this one is also degree 3. So we want to write this one in the second and this one in the first. It doesn't matter whether you flip the position. But I think it is better to be consistent with the variable x. So I wrote x squared, then x, and no x. And degree 3, and degree 3, and this one is degree 2, 6 is degree 0. In this algebraic expression, we have degree 2 polynomial because this is the highest degree, and this is the highest degree, and this is the highest degree in the third parenthesis. So degree is 2. Degree 2 polynomial. We can rewrite this as -6v squared plus 9v minus 1 plus -1 times 9v squared plus 8v minus 6 plus minus 6v squared minus 4v minus 4. So we have to multiply by -1 to the second parenthesis. Let's copy what was in the first parenthesis. That's -6v squared plus 9v minus 1 minus 9v squared, and then minus 8v minus 1 times 6 plus minus just do jar minus 6v squared minus 4v minus 4. Then I want to collect the degree 2 terms because we have degree 2 polynomial, and that's the highest degree term. We have degree 2 term here, degree 2 term here, degree 2 term here. So let's take out -6 and then -9 and -6 times v squared. The degree 1 terms is this one, and this one. So we have to write plus parenthesis 9, and we take care of the coefficient -8 and -4v. Lastly, we think about those numbers, constant terms. Those are -1, and this one minus will make plus, so +6 -4. So we have -21 v squared plus -3 v and +1. We can express this as -21 v squared minus 3v plus 1.